Hello dear students, welcome everyone, welcome to another lecture of engineering mechanics in your own buoyancy batch on your own YouTube channel Unacademy GATE, ESE and PI. Welcome, good evening Mustafa. So this is lecture number 31 of engineering mechanics and kinematics of rigid bodies, rotational motion part 2. Yesterday we started rotational motion. Till now we were studying about translation motion, kinematics of translation, kinetics of translation. Yesterday we started kinematics of rotational motion. So we are going to continue that today also. Good evening Hari Krishnan, good evening Nuva, good evening, good evening, good evening. So beta, tell all your friends that we are live and we are studying rotational motion. Call all your friends, share the link with all your contacts and show your support and love. And those of you who are online, please hit the like button. Please hit the like button once and show your love and support. Thank you so much Hari Krishnan. Thank you so much beta. So if you want us to keep performing like this, if you want us to keep making contents like this, keep making videos like this, you need to show your love and support. How you can show your love and support? Just one like and one share will do everything beta. Just one like and one share. Share this link in your WhatsApp groups. You might have college WhatsApp groups, you might have WhatsApp groups of your classmates. So please send this link to that group. Tell everyone, see, we are taking lectures day and night here beta, so that everyone in India will get hands-on free of cost education, quality education. So we want these videos to be seen by every student of India. We want all of you to get the benefits of these classes. So that's why we need your support in that. And how you can support it? By sharing it. So keep loving and keep sharing. Thank you so much if you have already done it. Thank you so much if you have already done it. Thank you so much. Good evening Somnath. Thank you so much Khandeep. Thank you so much Hari Krishnan. Thank you so much Nishi. Now beta, if you are watching me for the first time, my name is Aprup Rao, All India rank 320 from GATE Mechanical. I was recruited by IOCL but I never went. I wanted to join IIT, so I went to IIT Kharagpur and my specialization was mechanical systems design. Then in my final year I was recruited by Mahindra. I worked at Mahindra Research Valley, which is the R&D of Mahindra automobiles and tractors. All the cool cars of Mahindra are designed there. XUV 500, KUV, TUV, all these vehicles are designed there. So I was there for 2 years as deputy manager, and then I quit my job and I started teaching. So I've been teaching for more than 6 years now, and I teach all the subjects related to design. You can see my love for design from the very beginning beta. My MTech is from design, my work is from design, and then my 6 years of teaching is also based on design. So you can see my love for design subjects, and I promise you, if you keep watching my lectures, you will also fall in love with the subjects of design. You will also fall in love with the subject of design. Which year you studied in IIT Kharagpur? Beta, I was in Kharagpur from 2010 to 2012. Okay, now if you want to download our lecture notes, go to the description of this video. You will find the link of our Telegram channel. So click on this link, you will go to our Telegram channel where you will find the lecture PDF of all the lectures we take on YouTube. And if you want to download my personal notes and ebooks, then you can go to tinyurl.com/approve10. This works as a website. Put it in your web browser, tinyurl.com/approve10. You will go to this drive where you will find the folders of all my books and notes, and you will also find an Excel sheet. In this Excel sheet, I put the links of all my Unacademy special classes. Apart from YouTube classes, you can also watch my lectures free of cost on Unacademy. It's called Unacademy Special Class. So my special class links will be in this Excel sheet. Every day after the YouTube class, we have DPP sessions. DPP means daily practice problems. So if you want to practice problems of engineering mechanics with me, you can attend these DPP sessions and you will find the link here. So today also we have DPP session. Today at 11 PM. Beta, the time of DPP session has been changed. The time of DPP session has been changed from 9:30 to 11 p.m. So today at 11 p.m. DPP session beta. So come for this session at 11 p.m. Okay, instead of 9:30 p.m. we have moved it to 11 p.m. because you have another lecture after this. You have another lecture on manufacturing by Prakhar sir. Don't forget to watch that lecture after this. Okay, and if you want to connect with me, you can find me on Facebook, you can find me on Instagram, or you can directly call me. It is better if you call me. Even if you have any doubts, people usually send messages to me beta. It is very hard for me to track down your problems. Okay, so that's why I prefer that you call me. You call me. If I am busy, then I will not pick your call and I will call you back. If I am free, I will pick up your call. Okay, so better you call me and discuss all your doubts. And if you want to plan your strategy for GATE, if you want my guidance for it, then beta you can call me and we will discuss it over the call. Okay, thank you so much, and let's start the lecture beta. So we were discussing rotational motion. So let's first understand where this fits. Okay, so beta we are studying the dynamics of bodies. Dynamics means motion of moving, study of moving bodies, right? Statics part is over. We are studying dynamics. Now in dynamics, the syllabus is divided based on the type of motion. So we divide the motion into three categories: translation, rotation, and general motion. Now in translation motion, all the particles of the body move with same displacement, velocity, and acceleration. So in this case, we consider the body as a particle. Okay, so when I say kinematics of particle or kinetics of particle, it is the study of translation motion. And in case of rotation and general motion, all the particles have different velocity, different displacement, different acceleration. So in this case, we can't assume the body as a particle. We need to assume it as a rigid body. So when I say kinematics of rigid body or kinetics of rigid body, it is rotation or general motion. Rotation or general motion. So beta right now we are studying rotation. Right now we are studying rotation. Tomorrow we will start general motion. Okay. Now beta, what is rotational motion? It is circular motion about a fixed axis, about a fixed center of rotation. So look at this beta, look at this case. This is a fixed center of rotation. These gears are rotating. They are in circular motion about a fixed center of rotation. Look at the blades of this fan. They are also rotating about a fixed axis of rotation. So axis of rotation or center of rotation is fixed and the body is in circular motion. So that is known as rotational motion. So you see various examples in your daily life of circular motion beta. Grinding wheel, the motion of grinding wheel is also circular motion. Flywheel, that is also circular motion. Okay, motion of wheels of vehicle is not circular motion beta, because the wheel of vehicle is rotating as well as translating. It is going forward as translation motion. So beta there is rotation and there is translation motion. So that is a different example. That is a different example. Here the center of rotation is fixed. Here the center of rotation is fixed. In case of wheels of the vehicle, car, bicycle, bike, anything, in that case the center of rotation is not fixed. The center of rotation itself is moving. So that's a different story beta. This is the case where the center of rotation is fixed. The center of rotation is not moving anywhere. So beta the body is in circular motion about center of rotation, a fixed center of rotation. That is pure rotational motion. Now yesterday, one moment. Yesterday we discussed how to calculate the angular motion variables, angular displacement, angular velocity, angular acceleration. Today we are going to discuss how to calculate linear velocity, linear displacement and linear acceleration. Good evening Manas, good evening Manas. Now I need to change a few changes in slide. So please pardon me. I was just practicing and it is still there. One moment. Okay, let me just skip it. Okay, so yesterday we were discussing how to calculate the angular motion variables, right? And I took the example of a bar. So let's say we have a bar like this. It is hinged. Okay, now initially the bar is like this, and after some time the bar goes to here. Okay, it is having rotational motion in anti-clockwise direction. Now consider any 2 points. Let's say this is point A, this is point B. So initially they were here, and after some time A reached to here, A dash, and B reached to here, B dash. This was our example, right? Now this is the center of rotation. O is the center of rotation, which is fixed. This is fixed. Now beta, yesterday we saw how to find the angular motion variable. So beta, the first angular motion variable was angular displacement, right? Theta. Then angular velocity, omega. Angular acceleration, alpha. And what was the relation between them? Angular motion variable, omega equal to d theta by dt, alpha equal to d omega by dt, and sometimes we also use this in some rare cases, alpha equal to d omega, omega into d omega by d theta. This was the relation between angular motion variables, right? Angular motion variables. Now angular motion variable of all the particle will be same. Theta, omega, alpha will be same for every particle. Look at this beta. A is rotated by theta angle, so B is also rotated by theta angle. If you consider another point C, that will also be rotated by theta angle only. So beta, theta, omega and alpha for all particle is same. So angular motion variables are same for every particle, but linear motion variables are not same for every particle. Okay, let's understand how. So the first motion variable that we are going to see, linear motion variable. Linear motion variables. The first linear motion variable that we are going to see is displacement. First linear motion variable that we are going to see is displacement. So beta, how we can calculate the displacement? Look at this beta. A is moving from A to A dash. So this is the linear displacement of A to A dash, right? Linear displacement of A is A to A dash, right? Displacement of A equal to AA dash, right? And what will be AA dash? If you look at this arc length, can I write it theta into OA? Right? And if you see displacement of B, linear displacement. So how much distance B is covering? Beta? BB dash. And what is BB dash? Can I write it theta into OB? Yes. So beta, what you will get? Theta multiplied by distance from the center of rotation. Which distance? Radial distance. So beta, can I write linear displacement S is equal to theta multiplied by r, where r is what? R is what? Sorry, I am writing displacement. R is what? R is radial distance from center of rotation. Radial distance from the center of rotation. Okay. For example, let's say this is the body. Let's say this is the body. It is hinged at this point. Okay. Let's say this is the center of rotation. It is hinged and it is moving like this. It is moving like this. It is, let's say, moving in clockwise direction. It is rotating in clockwise direction. Okay. Now beta, consider any point. Let's say this is the point P. So beta, what will be the radial distance? If I draw a straight line, joining O and P, then this OP is the radial distance. O se P tak ka jo minimum distance hai, that is the radial distance. Is it clear to everyone? What is radial distance? What do we mean by radial distance? So beta, radial distance means from center of rotation to that particle, if you draw a straight line, then that straight line is the radial distance. Okay. So beta, look at this equation. S equal to theta into r. Clearly for every particle r will be different. हर particle के लिए r अलग होगा. For example, for A, r is OA. For B, r is OB. So for every particle, linear displacement is different. Angular displacement is same. Theta is same. But linear displacement is different. Is it clear? Look at this beta, look at this. From this diagram it is very clear. B is traveling more distance compared to A. B ज़्यादा distance cover कर रहा है A के comparison में. So the displacement of B is more than displacement of A. So beta, what will be the equation of linear displacement? S equal to theta into r. Okay. Now linear velocity. I don't need to write linear. If I am writing velocity means it is linear velocity. Okay. If I am writing velocity means by default it is linear velocity. Okay. So beta, how to calculate the linear velocity? What is the relation between V and S? V equal to ds by dt and S is what? Theta into r. So can I write d by dt theta into r? Yes, I can write it. Now beta, in this equation, r is the distance of that particle from center of rotation. So that is not going to change with respect to time na. If P moves from here to here, the distance will remain same. So r is a constant quantity that will come out of the equation. I will get d theta by dt. And what is d theta by dt? What is d theta by dt? D theta by dt is omega. D theta by dt is omega. So beta, what is linear velocity of any particle? Omega multiplied by r. Omega multiplied by r. So is it clear beta? Is it clear? What is linear velocity? V equal to omega into r. Again, omega for every particle will be same, but r for every particle will be different. So linear velocity for every particle will also be different. So angular motion variables are equal for every particle. Linear motion variables are different for every particle. Okay. Now beta, there must be some direction of velocity, because velocity is a vector quantity. So there must be some direction. So what will be the direction? Understand it. Let's say I need to find the velocity at point P. Okay. So I will join point B from point O to point O using a straight line. Now velocity at point P will be perpendicular to this line, like this. This is what? Velocity at point P, and it is perpendicular to this line OP. So do you understand how you can find the direction of velocity? If you consider any point, join a straight line from that point to center of rotation and it will be perpendicular. Now it is rotating clockwise, so velocity is down. If it is rotating anti-clockwise, this velocity will be up. Okay, so do you understand how to find the direction? Do you understand how to find the direction? Do you understand how to find the direction? This is d theta by dt, yaar. This is d theta by dt, d theta by dt. Okay, this is d theta by dt. So do you understand how to find the direction of velocity? At any point, if you want to find direction of velocity, join that point with the center of rotation and draw the velocity perpendicular to that line. Draw the velocity perpendicular to that line. So this is the magnitude of velocity, this is the direction of velocity. Yes, tangential. This is known as tangential. Okay, at any particle, at any point, velocity is tangential to the path. Okay, velocity is tangential to the path. Okay, now acceleration. Okay, so how we will find acceleration? Let me add a slide. ठीक है, एक slide add कर लेने दो. Okay, how we can find the acceleration? Let's understand that. How we can find the acceleration? Now beta, acceleration we need to understand. यहां ध्यान से देखो. Let's say initial velocity of A is UA. It will be perpendicular to this line. Final velocity of A is VA. So it will be perpendicular to this line. है ना? It will be perpendicular to this line. UA is perpendicular to this line. VA is perpendicular to this line. Now understand beta, understand. The velocity of A is changing the magnitude. The magnitude of velocity at A is changing from UA to VA, and the direction of velocity is also changing. UA was vertical and VA is inclined at some angle. So beta, the direction is also changing. So beta, here two things are happening. The magnitude of velocity is changing from UA to VA and the direction of velocity is also changing. So here there are two components of acceleration. One component of acceleration is changing the magnitude of velocity and one component of acceleration is changing the direction of velocity from here to here. So beta, here there will be two components of acceleration. The first component of acceleration is AT, which is known as tangential acceleration. Now what is tangential acceleration? It causes change in magnitude of velocity. Okay, velocity is changing magnitude and direction. So okay, UA se leke VA, the magnitude is changing. So beta, this is the cause of that change. And how we will calculate it? dV by dt. With respect to time, magnitude of velocity is changing. Now beta, can I write it d by dt omega into r? Again r is constant. So it will come out of the equation. You will get d omega by dt. ठीक है? Now what is d omega by dt? Alpha, angular acceleration. So AT can be written as alpha into r. This is the tangential acceleration. Is it clear? How magnitude changes when omega is constant? Beta, who told you that omega is constant? Did I say omega is constant? Omega is changing with respect to time and you are saying that omega is constant. Omega is changing with respect to time. Here I am differentiating omega and you are saying that omega is constant. Did I say? कहीं पे बोला मैंने पूरे लेक्चर में? अज्यूम मत करो यार, मैंने यहां पे कहीं बोला ही नहीं है कि ओमेगा कांस्टेंट है. ओके, नाउ बेटा tangential acceleration is the cause of change in magnitude of velocity. What will be the cause of change in direction of velocity? an, which is known as normal acceleration. Now normal acceleration causes change in direction of velocity. It causes change in direction of velocity. Okay, so the direction of velocity is also changing. Look at this, ua is in this direction, va is in this direction, so the direction is also changing. So beta, this is the cause of change in direction of velocity. Okay, and how this is calculated? an is given by v square divided by r. If I put v equal to omega into r, then it will become how much? Then it will become how much? It will become, sorry, it will become an equal to omega square into r. Omega square into r. So understand this beta, at is alpha into r, an is omega square into r. Now these are the magnitudes. These are the magnitudes. We also need to see what will be the direction of at and an. Okay, so again pardon me, I have to add one more slide. I'm so sorry for this. I'm so sorry for this. 2-3 slide add कर देता हूँ. Okay. All right. Now, what will be the direction of at and an? Let's see that. Okay. So here, let's consider. एक second. Let's consider again. This is the body. It is rotating with respect to a fixed axis, let's say clockwise. Okay, and this is the particle where I need to find direction of at and an. Okay, so first of all, what I will do, I will draw a straight line. I will draw a straight line from O to P. I will draw a straight line from O to P. Now direction of at will be same as direction of velocity. Direction of at will be same as direction of velocity. It will be perpendicular to this at, just like velocity, it will be perpendicular to this. Now direction of an will be very simple, towards the center of rotation. an will be towards the center of rotation. at is perpendicular to this line and an will be towards this line, along this line, towards the center of rotation, ठीक है. तो at की डायरेक्शन ये हो गई, an की डायरेक्शन ये हो गई. now beta there will be resultant of at and an. कुछ resultant आएगा इसका at और an का. let's say that resultant is a. So a is what? Resultant of at and an. So a will be equal to root over at square plus an square. Root over at square plus an square. And you can also find the direction. ठीक है, इस triangle से you can also find the direction of this acceleration. So you can clearly see that the acceleration and velocity are not in the same direction. A and V are not in the same direction beta. At and V are in same direction, but A is the resultant of at and an, and the direction of A and direction of V are different. In translation motion they are same, but in rotational motion direction of velocity and direction of acceleration are different beta. The direction of velocity and direction of acceleration are different. So is it clear to you? Beta, how to find displacement, velocity and acceleration? Displacement is theta into r, velocity is omega into r, acceleration have two component, alpha into r and omega square into r. So beta, in order to find linear displacement, linear velocity and linear acceleration, I need theta, I need omega, I need alpha, right? In order to find linear displacement S, we need theta. In order to find linear velocity V, we need omega. And in order to find acceleration at, we need alpha, and in order to find an, we need omega, right? Then a will be root over at square plus an square. So beta, in order to find these three things, we need theta, omega and alpha. So yesterday we saw problems where we are calculating theta, omega and alpha. Today we will see problems where we will calculate S, V and A. We will calculate S, V and A. Linear displacement, linear velocity, linear acceleration. Usually linear displacement is not calculated. Usually they will ask you to calculate linear velocity and linear acceleration. Okay, so shall we see the problems related to this? Shall we see the problems related to this? Shall we see the problems related to linear displacement, velocity, acceleration? Chalo, chalo, chalo. So the first problem in front of your screen, a wheel of 1.2 meter diameter starts from rest and is accelerated at the rate of 0.8 radian per second square. Okay, so it is starting from rest, means omega naught is 0. Okay, omega naught is initial angular velocity at the rate of 0.8 radian per second square. So beta, this is alpha, which is constant. Alpha is constant. Find the linear velocity of a point on its periphery after 5 seconds. Okay, so you need to find linear velocity. What is linear velocity? Omega into r. So I need to find omega first. Okay, I have omega naught, I have alpha and I have t. So how I will find omega? If alpha is constant, I can use this equation. If alpha is constant, I can use this equation, omega naught plus alpha t. Omega naught is 0, alpha is 0.8 and t is 5. So omega is how much? 4 radian per second. So this is the final angular velocity after 5 seconds. But I don't want angular velocity, I want linear velocity, right? So beta, this is the wheel. Okay? Let's say it is rotating about the center. Now I want the velocity at a point on the periphery. So what will be the radial distance beta? What will be the radial distance? R will be equal to what? The diameter is 1.2 meter. So radius will be 0.6 meter. Okay, you have to put it in meter. I want velocity in meter per second. So you have to put the distance in meter. Okay, now beta, velocity of P will be omega into R, means 4 meter per radian per second multiplied by 0.6. So velocity of P will be 2.4 meter per second. 2.4 meter per second. 2.4. Yes, Ajay. Very good, Pushpesh. Very good, Vamsi. Very good, Vankata. Very good, Akshay. Very good, Yogesh. बहुत बढ़िया, Prem. Very good, beta. Very good, very good, very good. So do you understand how you can calculate linear velocity, linear acceleration? You can also calculate acceleration based on the value of alpha and omega. Alpha और omega से acceleration भी निकाल सकते हैं. ठीक है? Very good, Nuva. Very good, Umesh. Very good, Mithilesh. बहुत बढ़िया, बहुत बढ़िया, बहुत बढ़िया. So shall we move on to the next question? This was an easy question. In order to start, exercise start ही कर रहे हैं, तो अभी पहला थोड़ा आसान था. Let's move on to the next question. Very good, Mahadev Prasad. Let's move on to the next question. अगले question की तरफ बढ़ते हैं. थोड़ा सा difficulty level increase करते हैं. A cord is wrapped around a wheel which is initially at rest. एक cord है, a cord is wrapped around a wheel which is initially at rest. If a force is applied to the cord which gives it an acceleration of 4t meter per second square, where t is in second, find the angular velocity of wheel after 10 seconds. Okay, so let's say this is the wheel. let's say this is the wheel, okay, it is, let's say, hinged at the center, so this is my center of rotation, okay. A cord is wrapped around a wheel, ठीक है, तो एक cord है जिसको मैंने इसके चारों तरफ लपेट दिया है, रस्सी, cord means रस्सी, okay, and then I am applying some force to this cord which is giving this rope, which is giving this cord an acceleration of 40 meter per second square, okay. Find the angular velocity of the wheel after 10 seconds. Find the angular velocity of the wheel omega after 10 seconds. Now understand this, beta. Understand this. How we can find it. Okay. First of all, you need to understand this concept, beta. Whenever a cord is wrapped around a wheel, whenever a rope or cord is attached to the periphery, okay, and if there is no slip, अगर cord और इस body के बीच में कोई slip नहीं है, if there is no slip, between cord and wheel, then beta, understand this. Let's say this point is P. Okay, let's say this point is P. Then according to no slip condition, whatever is the velocity of this cord, whatever is the velocity of cord will be velocity of P. Velocity of cord will be equal to velocity of P, because there is no slip. Because there is no slip, so relative velocity at this point should be 0, right? If there is no slip, the relative velocity should be 0, right? If two bodies are connected together and there is no slip, both are moving, there is no slip, then there must be no relative velocity. If there is slip, if one body is slipping over the other body, there will be some relative velocity. So here there should be no relative velocity. So whatever is the velocity of the cord should be equal to the velocity of point P. Okay. Second thing, acceleration of cord. Acceleration of cord will be equal to tangential acceleration of P. Okay, not the total acceleration, tangential acceleration of P. Okay, if velocity at P is equal to velocity of cord, then tangential acceleration of P will be equal to acceleration of cord. So beta, these are the 2 points which you need to remember in order to solve these type of problem. In order to solve this type of problem, you will see a lot of these type of problem. Okay, belt and pulley problem, okay, rope and pulley problem. In those problems you will apply the same concept. Whenever there is no slip, then beta, velocity of the cord will be equal to linear velocity of P, and acceleration of cord will be tangential acceleration of P. Okay, so here beta, acceleration is 4t. This is the acceleration of the cord. So this will be the tangential acceleration of this point. Okay, let's consider one point. Let's consider this point P. Okay, so this acceleration will be tangential acceleration of P. Na, I can write this. Tangential acceleration of P will be equal to 4t. This acceleration. Now, what is the equation of tangential acceleration? Alpha into r. Okay, alpha into r. So alpha into r of P will be equal to 4t. Now what is r of P? What is r of P? 1 second. Sorry, the diagram is not given. Okay. So sorry. The radius is not mentioned. Let me give it to you. Let's consider it 200 mm. इसको 200 mm ले लो. ठीक है? 200 mm ले लो. Now beta, chord is okay. So beta, what will be this? Alpha into 0.2 equal to 40. So alpha will be equal to how much? Alpha will be equal to how much? In terms of t, alpha will be equal to how much? In terms of t, alpha will be equal to how much? कितना हो जाएगा? कितना हो जाएगा? कितना हो जाएगा? 4 by 0.2. 4 by 0.2. 20t. Okay. So beta, alpha is in terms of t, and now I need to find omega. Now I need to find omega after t second. So what will I do beta? I will integrate it. Alpha equal to d omega by dt. Okay. So I will write d omega equal to alpha dt. I will integrate it. Initially it was at rest. So this will be 0. Finally omega. Okay. And what is the time? Initial time 0. Final time 10 seconds. So this will be omega equal to, what is alpha? 20t. तो 22 को इंटीग्रेट कर देंगे तो क्या हो जाएगा? 20t square by 2 from 0 to 10. तो 10t square. Okay. तो 10 into 10 का square 1000 radian per second. 1000 radian per second. Very good Sanju, very good Vamsi, very good beta, very good, very good, very good Palak, very good. So is it clear to everyone? First I calculated alpha in terms of t, and now I need omega, so I just integrated the equation. Yes Pushpesh, very good beta, very good, very good. बहुत बढ़िया Nikhil, very good Arshad. So is it clear to you how to solve these type of problem? Remember these 2 points. Velocity of chord will be equal to velocity of this point P. Acceleration of chord will be equal to tangential acceleration of point P. Very good Mahadev Prasad, very good Mithilesh, very good Hari Krishnan, very good Ajay. बहुत बढ़िया. Okay, okay. So beta, let's solve one more question based on the same concept. Okay, let's solve one more question based on the same concept. Let's solve this question. It is an interesting question and it is made of 3 different questions. 3 अलग अलग question है इसी question में. Okay, so beta, solve this. A pulley and 2 loads. This is a pulley. This is a pulley and 2 loads are connected by inextensible cords as shown. Load A has constant acceleration of 300 mm per second square. Load A जो है, it has constant acceleration of 300 mm per second square and initial velocity of 240 meter per second, both directed upward. Acceleration and velocity of A both are upward. Determine number of revolution executed by pulley in 3 seconds. First thing you need to calculate is number of revolution executed by pulley in 3 seconds. Now in order to calculate number of revolution, you need to calculate theta. In order to calculate number of revolution, you need to calculate theta. Now how you will calculate theta? Beta, here there is constant acceleration. Alpha will also be constant, and if alpha is constant, then you can apply equation of motion, 3 equation of motion. So in order to calculate theta, what do you need? Omega naught and alpha. Omega naught and alpha. Now omega naught I can calculate from here, initial velocity, and alpha I can calculate from here, acceleration, right? Beta, here initial velocity of A and initial acceleration of A is given. Both are upward. And beta, let's say this is point E. Let's say this is point F. ठीक है? A, B, C, D, E, F. So beta, this load, this cord is connected at point E, right? This cord is connected at point E, and I will assume there is no slip. So if there is no slip, then velocity of A will be equal to velocity of E. Velocity of this load will be equal to velocity of E. Right? Now beta, velocity of A is how much? 240 meter mm per second. Okay? And velocity of E will be how much? Omega naught Okay, omega naught, this is initial velocity. Okay, let me write it ue. इसको मैं ue लिख लेता हूं because it is initial velocity. Okay, so omega naught multiplied by r. E के लिए r कितना होगा? 120 mm. This is in mm per second. So this will also be in mm. So omega naught will be 2 radian per second, right? Omega naught will be 2 radian per second. Is it clear to you? Is it clear to you? Omega naught will be 2 radian per second. So omega naught we have calculated. What else I need? Alpha I need. Alpha. Okay. In order to calculate theta, I need omega naught and I need alpha. So beta, alpha how I will calculate? Acceleration of A is also given. 300 mm per second square, and it is constant. And it will also be equal to tangential acceleration of E. Right? Acceleration of A will be equal to tangential acceleration of E. Now what is acceleration of A? 300 mm per second square. Tangential acceleration means alpha into r. Alpha into r, and what is r? Again 120. So alpha will be equal to what? 300 by 120. कितना आता है? My maths is not that great, beta. 2.5. 2.5. 300 by 120 पक्का? Yes, 2.5 radian per second square. So now I have omega naught and I have alpha. So can I calculate theta by applying equation of motion? Which equation of motion we will apply? Theta equal to omega naught into t plus half alpha t square. Okay. Now omega naught we have 2. Time is what? Time is what? 3 seconds plus half alpha is 2.5 into 3 square. So I will get the value of theta 6 plus 4.5 into 2.5. 6 plus 4.5 into 2.5. 17.25 radian. But beta, I don't want theta, I want number of revolutions. And number of revolutions, one complete revolution means 2 pi radian. One complete revolution means 2 pi radians. So it will be theta by 2 pi, है ना? 17.25 by 2 pi. So how much are we getting? 17.25 divided by 2 pi. 2.75, around 2.75. Okay, so this is one answer. This is the answer of question number A. It will execute 2.75 revolutions. Okay. Now the second question is velocity of load B after 3 seconds. Now if you want to calculate velocity of load B, it will be equal to velocity of F. And how I can calculate velocity of F? Omega into r of F. Now r of F is given 180 mm, but omega I don't know, but I can calculate omega because I have omega naught and I have alpha. I have omega naught and I have alpha, so I can calculate omega, right? So after 3 seconds, after t equal to 3 seconds, omega will be equal to omega naught plus alpha t. Omega naught is how much? Omega naught is how much? Omega naught 2 plus 2.5 into 3. So 7.5 into plus 2, 9.5 radian per second. Now velocity of B will be equal to velocity of F, which will be equal to omega into r of F. Okay, so omega is 9.5 and r of F is how much? 180 mm. Okay, 180 mm. So I will write it in meter, 0.18. I will write it in meter, 0.18. So how much I will get, beta? How much I will get? 9.5 into 0.18 कितना आएगा? या फिर इसको mm में ही निकालो, mm पर सेकंड में ही निकाल लेते हैं, ठीक है, क्योंकि सब तो उसी में ही दिया हुआ है. So 180 into 9.5. 1710 mm per second. 1710 mm per second and 1.71 meter per second. Okay, 1.10 mm per second or 1.71 meter per second. Okay, so this was the second answer. This was the second answer. Okay, then acceleration of point D. Acceleration of point D at t equal to 0. Now in order to calculate acceleration, we need AT and AN both. ठीक है? So at t equal to 0, what will be AT? Alpha into AT किसका? Point AT किसका? Point D का. Okay. So AT of point D will be equal to alpha of R into D. Alpha is how much? Alpha तो constant है, उसका time से कोई लेना देना नहीं है. It has nothing to do with time. And RD is 120. Okay. So AT of point D will be equal to how much? 120 into 2, 240, 300. अरे यार ये मैंने क्यों किया? AT तो पहले से पता था ना. AT तो already हमको पता ही था. Sorry. We don't need to do. We already know ना AT. AT तो already पता है. AT तो already पता है 300 mm per second square. वो तो दिया हुआ है ना क्वेश्चन में. We need AN. AN will be equal to what? Omega square into R. And at t equal to 0, omega was omega naught. है ना? और omega naught कितना है? 2 into 120. So AN at point D will be equal to how much? 480 mm per second square. So acceleration at point D will be equal to root over 80 square means 300 square plus AN square means 480 square. So acceleration at point D, total acceleration, this is the total acceleration. Okay, this is the total acceleration, root over 300 square plus 480 square. So it will be 566, around 566 mm per second square. 566 mm per second square. So is this the answer everyone is getting? Is this the answer everyone is getting? Yes? Yes. Very good beta, very good Akshay. Very good, very good, very good. So beta, this is the acceleration at point D at t equal to 0. At t equal to 3 seconds, you can calculate the acceleration. At t equal to 3 seconds, AT will remain same because alpha is constant, but AN will change. At t equal to 3 seconds, AN will change. AT will remain same. Alpha into R में alpha is constant, so AT will also be constant, but AN will change because omega will change. So here I will write omega, not omega naught. At t equal to 3 seconds, this will become omega, okay, not omega naught. At t equal to 0, it is omega naught. At t equal to 3, it will become omega. So acceleration at point D at t equal to 3 seconds will be different, okay. Yes, 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 very good. Thank you so much Hitesh, thank you so much beta. Hit the like button once. एक बार तो लाइक बटन दबा दो यार, दबा दो दबा दो. वेरी गुड अक्षय, वेरी गुड हनी, वेरी गुड वंकटा, मुस्तफा, बहुत बढ़िया, बहुत बढ़िया. वेरी गुड पुष्पेश, वेरी गुड, वेरी गुड, वेरी गुड. So beta, do you understand how to solve these type of problem when a rope is connected to the pulley? So beta, how to calculate, how to find out the linear displacement, linear velocity, linear acceleration? Is it clear? Is it clear? So this was calculation of linear displacement, linear velocity and linear acceleration. Linear displacement, linear velocity, linear acceleration. Okay, if you want to solve some more problems, then beta you are welcome to join us. Welcome to join us in the DPP session. Okay, today 11 PM. This is today. आज रात को 11 बजे. Today at 11 PM we have a DPP session on kinematics of rotational motion. We will see kinematics of pure rotational motion. So in yesterday's lecture we saw how to calculate angular motion variable. In today's lecture we saw how to calculate linear motion variable. So combined DPP we will solve in today's class. We will solve today's class practice problems of yesterday's lecture and today's lecture. Okay, so everyone please join me at 11 p.m. Everyone please join me at 11 p.m. How you will find the link? Go to tinyurl.com/approve10, open this Excel sheet, and here you will find the link. Okay, so everyone please join me at 11 p.m. I have already told you guys, if I don't get 50 to 60 students today, if I keep getting students very less, then beta DPP sessions will be stopped, because I am trying this, I am doing all this so that students can get benefit. But if no one wants to get the benefit, then for whom I am doing all this? Yes Rajneesh, I will put it. मैं अपलोड कर दूंगा बेटा, एक साथ अपलोड कर दूंगा, ठीक है? Okay. Now beta, those of you who want to start your preparation with us, if you like my teaching, if you think that you will get the benefit of my guidance, my mentorship, you will get the benefit of all my practice sheets, you will get the benefit of all of my team members, then beta join this target batch. Every day we are having 3 to 4 lectures. Every day we are having 4 lectures. The syllabus will be completed by the end of December, and we will start the revision process in January. Every day students are joining this batch. Okay, since the last 3 days we are seeing that every day students are joining, and they are happy about it, because now they don't need to open the textbooks, they don't need to worry about the syllabus, they don't need to make their own schedule. We have their own schedule, we have made them a schedule. They don't need to search for the practice problems. They can ask doubts anytime, and their doubt is immediately resolved. So they are getting all the package, they are getting the entire package, they are getting everything, so that their time will not be wasted, because now we have only 5.5 months. So the time is very crucial beta. Now you cannot even waste 1 minute. So if you don't want to waste your time in finding the lectures, finding the notes, finding the practice sheets, waiting for the doubts to be solved, if you don't want to waste your time, if you want to maximize your output, join us in this target batch. This target batch is specially for you. We were not planning to launch this batch, but when we saw that lots and lots of students are interested, then we thought of launching this batch specially for you people who are not very bright, who are not very excellent. If you are just average student, you can still crack GATE. Don't lose hope. अगर आप ये सोच रहे हो कि नहीं मैं average student रहा हूं तो मैं crack नहीं कर सकता GATE, मैं सिर्फ qualify कर लूं उतना बहुत है, that is not true. If you will put your hard work, if you will be dedicated enough, and if you will be confident enough, then beta I am sure then you will do better. If you join this batch, you can do wonders. I am not saying that without this batch you cannot prepare for GATE, but all I am saying is don't take risk. अगर आप अभी ये सोच रहे हो कि आपकी 2000 रैंक आएगी, तो यहां बैच ज्वाइन करने के बाद आपकी कम से कम 1000 तो आएगी ही आएगी. So you will always get better result. Okay, I am not saying that you cannot crack GATE without this. All I am saying is कि अगर if I give you a push, अगर मैं आपकी थोड़ी help कर दूं, then you will get a better result. Your output will be optimized, maximized if your time is not wasted. If you are utilizing this time fully, completely, then you can optimize your efforts, you can optimize your output. So if you want to optimize your output, join this batch. And those of you who are in their 2nd year or 3rd year and having problem maintaining balance between academics and GATE preparation, then this is the batch for you. अगर आपको भी balance करने में problem हो रही है कि कॉलेज भी मेंटेन करना है, कॉलेज में मार्क्स कम नहीं होने चाहिए, यूनिवर्सिटी में मार्क्स कम नहीं होने चाहिए, और यहाँ गेट की भी प्रिपरेशन करनी है, कौन सा सब्जेक्ट पढ़ें, कौन सा सब्जेक्ट इस सेमेस्टर में है, सो बेटा दिस इज द बैच फॉर यू, बायंसी प्लस बैच, where we have started machine design, engineering mathematics, heat transfer. machine design, heat transfer बहुत लोगों के syllabus में भी है, and the timing is such that it will not clash with your college timing. and we are designing the syllabus in such a way that it will help you in your university exam as well as your GATE exam. So if you want to make balance between your GATE preparation and university exams, then this is the batch for you, for second year and third year students, okay? And what are the other advantages? You will get crash courses for every exam, whatever exam is there, whether it is BARC, ISRO, DRDO, whether it is ESE, whatever exam is there will be some crash course for that. There will be rank improvement batch. Rank improvement batch is especially for those students who have completed basics and they just want to practice problems. So in every stream, we are solving 3000 to 4000 problems, new problems, specially designed for this batch. So if you want to join this batch, come to Unacademy beta. All the classes will be in English and Hindi, so you will have no problem with the language. आपको language की कोई problem नहीं आएगी, वो हमारी guarantee है. There will be dedicated doubt clearing sessions as well as doubt clearing groups. So all your doubts will be resolved within hours, and there will be weekly tests, so you don't have to join a separate test series. So everything you will get in the Unacademy Plus subscription. If you want to take the subscription, go to Unacademy app, click on the get subscription button. 1 month, 3 months, 6 months subscription is not for you. आप लंबी रेस के घोड़े हो तो आपको या तो 1 year का सब्सक्रिप्शन लेना है, because beta now ESE notification is also released. So next year in July there will be ESE exam. So if you were targeting only for GATE, now you can target for ESE also, because if you complete syllabus of GATE, then ESE का आधा syllabus हो गया, only general studies is left, and that you can study after GATE. You will have 4 to 5 months complete time to cover the general studies topics, okay? So you can also prepare for ESE if you take 1 year subscription, and if you are in 22, then to you, if you are targeting 22, GATE 22, then to you only have to take 2 year subscription, okay? There is not much difference between 6 month, 1 year and 2 year subscription. So 1 year and 2 year will be the most advantageous for you. Per month cost will be very less, okay? And don't forget to put this referral code. This referral code will connect you with me and my team, and it will also give you a 10% off. So you don't have to pay 25,000, only 22,500. You don't have to pay 30,000, only 27,000. So you can see how affordable the education is nowadays. And you will get multiple educators and multiple batches. Usually in academies, you pay a hefty amount of fee for one batch. You will get a set of teachers. If you are not able to understand from someone, then it's your problem. But here, that's not an issue, because we have multiple educators, we have multiple batches. So you can join any batch, you can watch any lecture, there is no limit on the learning, and all this only in one subscription. One subscription, multiple batches, multiple educators. This facility will not be provided anywhere else and at this affordable cost. So if you want to join Unacademy, then beta call me on 7000-534-184. You can also take this subscription on EMI. The EMI is available on credit card as well as debit card, and nowadays Bajaj Finance option is also available. So a lot of people have Bajaj Finance cards. So through this card also you can pay the amount in EMI. Only 1875 rupees per month or 60 rupees per day, and you will get infinite number of lectures, infinite number of support, infinite number of guidance, okay? But don't forget to put approved 10 as your referral code in order to get 10% off, and in order to get connected to me, in order to get the personal attention of me, personal guidance of me, okay? So beta, if you want to talk about it, call me and we will talk about it. We will plan your entire strategy, okay? Now I will see you at 11 PM. If anyone is not aware of it, let me repeat again. At 11 PM we have a DPP session. Usually we used to have DPP session at 9:30 PM. Now I have changed the timing to 11 PM. So I will see you at 11 PM on Unacademy special class. How you will find the link? tinyurl.com/approved. Okay, so I will see you there. Thank you so much. Bye bye.